to cloud. We get part 1 last time, the first type. Now let's do the second type. Let's do the second type. What is the second type? Type 2 is the one with qx, the denominator of that rational integrand, contains linear factor with repetition. Contains linear factors with repetition. For example, let's see number 19. Now you will see the focus, even though we do integration, but the focus is more into the partial fraction decomposition. Number 19, we have integral from integral of x squared plus 1 over, they factor it for us, x minus 3, x minus 2 squared dx. Now, then I do partial fraction decomposition. So x squared plus 1 over x minus 3, x minus 2 squared. So you see the repetition actually happens here, right? It's multiplicity of 2. So x minus 3 happens only once. It's multiplicity of 1. So we have only one x minus 3. For x minus 2, because it's squared, then we will have x minus 2 and x minus 2 squared. Like that. Okay, so if I write it down, like try to break it up, x minus 3 have simple multiplicity. Okay, while x minus 2 has a square. So you start with the power of 1 up to the power of 2. If you have instead, if what you have here instead is the power of 3, then you will have here x minus 2, x minus 2 squared, x minus 2 cubed. Like that. Okay. Now, the rule for the numerators is always 1 degree less than the denominator without considering the repetition. So the first one here, this is the denominator is degree of 1, so this is just degree of 0 or constant. Degree of 1 at the bottom, so on the top degree of 0. Okay, here, even though the bottom have a square, but it's actually coming from a repetition for x minus 2, right? So 1 degree less than that degree of 1, that's just C, like that. Any questions so far? No question? Okay, now then from here, I will multiply this by the LCD, which is x minus 3, x minus 2 squared. So on the left-hand side, we have x squared plus 1. I'm sorry, I'm dying. And then the right-hand side, a times x minus 2 squared, b times x minus 3, x minus 2, and c times x minus 3. Okay, now before I go on, let me tell you what's the weakness of a special value method. Notice here the special value method, we can only use 2 special value methods that make it 0, right? X equals to 2 and x equals to 3, is it right? But we have 3 variables. We have A, B, C. You see? Okay, so using 2 special value may not give us all A, B, and C. Okay, So let me plug in numbers. So when x equals to 2, this is 2 squared plus 1 equals to 0 plus 0 plus negative 1c, so negative c. This is 5 equals to negative c, so c equals to negative 5. Okay, we are done with 1. Right? Okay, and then when x equals to 3, that's 3 squared plus 1 equals to a plus 0 plus 0. So a equals to 10. So what special number can we use for to get the b? Okay. Well, it doesn't have to be 2 and 3 though. We purposely chose 2 and 3 because it kills the most terms, right? Okay, but you can actually choose 1 if you want. Okay, you can choose 4. Okay, you can choose 4. So let me show you here. Let me show you here. From here, we still need to find the b, right? So one way is you choose another x that don't kill all terms, but at least simple enough. Let's say when x equals to 1, let me choose x equals to 1. So it'll be 1 squared plus 1 equals to a minus, actually plus 2b minus 2c. Imagine when x equals to 1, this is negative 1 squared becomes positive 1. Right? When x equals to 1, negative 2 times negative 1, that's positive 2. When x equals to 1, this is negative 2. Right? Now then I compute the left-hand side I get is 2. The right-hand side, a is 10, b is unknown, c is negative 5. So 2 equals to 20 plus 2b, which, why all of a sudden I feel something not right? Anyway, negative 18, so b equals to negative 9. Okay. Now then, from there we get x squared plus 1 over x minus 3, x minus 2 squared equals to 10 over x minus 3 minus 9 over x minus 2 minus 5 over x minus 2 squared. Okay, and then from there we can integrate. Any questions so far? Yeah, to integrate that, it's something we can do it really fast. So I worry about that later. Now let me look back. Notice that I use special value method all the way, right? I have only 2 very special value, but we have 3 variables A, B, C. So that's why one of the special value is basically a random number. Okay, you can choose x equals to 0 also. Don't get me wrong. You can choose x equals to 0. Okay, but I try to explain to you that we can do it another way. We can actually do it another way. We can actually do it another way. If you look into that polynomial x squared plus 1 equals to a x minus 2 squared plus b times x minus 3 x minus 2 plus c times x minus 3. Now take a look on the x squared component. On the left-hand side, you have only x squared. The coefficient is 1, right? Okay. Now on the right-hand side, you will have a times x squared, blah, 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 plus b times x squared, blah, 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 plus cx something, right? Maybe I write it this way. Hold on. On the left-hand side, that's x squared plus 1. Now on the right-hand side, if I semi-distribute that, I just try to stare at x squared term. Now then x squared component will be x squared equals to ax squared plus bx squared. Only those with x squared, right? And we know the a equals to 10. Okay, so basically then b must be -9. Now the thing is, sometimes you don't even need to write a lot of things down though. You just stare at this and say, okay, the x squared term, this is 1, this is ax squared, bx squared, no x squared term here. Right? So I don't really need to look at the x squared component, the x component and constant component to get all of them. No. I kind of mix it with the grouping method and special value method, you know. It doesn't have to be all Republican. It doesn't have to be all Democrat. Okay, yeah, it's like the mixture of them is actually an art. Okay, if that ability to play using either one method or even use both of them in this situation has become an art. Okay. And then we come up with the same b, which is -9. Then the next step is to integrate. But of course, the one on the left-hand side is something we cannot integrate until we decompose that partially. So this is integral of 10 over x minus 3 minus 9 over x minus 2 minus 5 over x minus 2 squared dx. Okay, so the first one is 10 natural log of x minus 3 minus 9 natural log of x minus 2. Okay, minus 5 times integral 1 over x minus 2 squared. How do you integrate this, by the way? Any idea?
Don't you want to use the u substitution?
U substitution. Okay, so I will do u substitution here, but I hope you can see that you try to skip that one. Okay, try to skip.
I mean, from seeing like the lecture problems you were giving, isn't it just 5 over 1? Sorry, 1 over x minus 2?
That's right, huh? So that's plus 5 over x minus 2. Don't forget plus constant, right? Just to make Thomas happy. It's indefinite integral, right? So supposed to be plus constant. We will practice more with this, but you know what? I remember one thing. I don't know if I somehow think I went over that with my lecture, but it would be nice if we go over that again here. An integral that, in my opinion, is very important, worth to know. Worth to know. Important integrals. It's so important that you want to memorize that. Oh, Dorlene, do you get my response to your email?
Yes, I did. I was able to figure out what I did wrong. Thank you. I emailed you back saying thank you.
Oh, I didn't even. Okay. Welcome. Good. Yeah, and I like it that way. You know, so I can answer you basically during my time. I can do it in writing, so you can follow me actually with your speed also. You know.
Okay, yeah, because I was like, okay, how do I send him my work and send them the problem, and I just send screenshots of everything.
yeah, that's actually the best.
Okay.
Integral secant theta is natural log of secant theta plus tangent theta plus constant. And we have couple times integral of secant cube theta d theta. Memorize this also. That's 1/2 secant theta tangent theta Is it plus or minus? I think it's plus. Plus 1/2 natural log of secant theta plus tangent theta plus constant. These things, when it shows up and you have to do it manually, it will be long. Okay, so it's better for you to just memorize that. Okay, there are more though, there are more, but others are, I think, quite easy to figure out. Now, we have one more integral with regard of partial fraction decomposition that shows up a lot. And in general, you need to know how to handle this integral. Integral of 1 over x minus a, x minus b. What will this be? Okay, now let's derive the formula. Okay, let's derive the formula. So we basically have x minus a, x minus b in the denominator. Okay, when we do partial fraction decomposition, it will be capital A over x minus lowercase a, capital B over x minus lowercase b, multiply by the LCD. We will get 1 equals to a times x minus b plus b times x minus a. Now, with special value method, when x equals to a, then 1 equals to a times lowercase a minus b. In other words, a is 1 over a minus b. Now, when x equals to b instead, I get 1 equals to b times b minus a. In other words, b is equal to 1 over b minus a. Or I can write it as negative 1 over b minus 1 over a minus b. Okay, therefore, 1 over x minus a, x minus b is equal to 1 over a minus b over x minus a minus 1 over a minus b over x minus b. Which I can factor 1 over a minus b out. Can you follow me so far? Now, therefore, if we go back to the integral, integral of dx over x minus a, x minus b, that will be the integral of 1 over a minus b times 1 over x minus a minus 1 over x minus b dx. Is that right? Now, 1 over a minus b is just a coefficient. I can bring it out. Now, the integral of 1 over x minus a is natural log of x minus a. The integral of 1 over x minus b is natural log of x minus b plus constant. But the guy inside the bracket may be simplifiable. So that's natural log of x minus a over x minus b plus constant. Okay, now suppose we just say that a is greater than b. If a greater than b, and I want a greater than b so that a minus b be positive. Okay, then it will be a lot easier to see. Now with this said, then let's use this formula. Suppose I need to compute. So how to compute, for example, integral of 5 over x minus 7 x plus 3 dx. So this is actually A. My B is -3. Okay, so this is 5 times 1 over A minus B, natural log of x minus A over x minus B, which we simplify, that's 1/2 natural log of absolute x minus 3 over x plus 3. That will be so nice to memorize. Okay, so I strongly recommend you to memorize this. Maybe I write it down here. So instead of keep on doing the same thing over and over and over again, every time you see that, then just come up with a formula that we will use a lot. Okay. Yeah, it will be quite helpful though. Yeah, otherwise you will spend so much time just to get the coefficients, and the simplification basically just that. Right? Okay. So one of the question there, may be useful for us to do. Let's see number 16. So I'm actually looking back into type 1. Type 1, number 16. That's integral from 0 to 1 of x cubed minus 4x minus 10 over x squared minus x minus 6 dx. And how do I do that? Well, it's improper fraction, right? So let's divide that first. Divided by x squared minus x minus 6. So this is x, give me x cubed minus x squared minus 6x, which when I subtract, I get x squared plus 2x minus 10. So that's plus 1. That's x squared minus x minus 6, which when I subtract, I get 3x minus 4. So this integral is equal to 0 to 1, x plus 1 plus 3x minus 4 over x squared minus x minus 6 dx. Okay, I go on further. This is 1/2 x squared plus x from 0 to 1 plus integral from 0 to 1 of that proper fractions. Let me factor it. Okay, now then you see you do partial fraction decomposition for this, right? 3x minus 4 over x minus 3 x plus 2. Basically, if you have improper fractions, make it proper first. Now, the method I show you here is the longer method. What do you mean, Thomas? You have shortcut? Not really a shortcut, just another way to do that. That may be faster. Okay, now I multiply by the LCD. So I get 3x minus 4 on the left-hand side. On the right-hand side, a times x plus 2 plus b times x minus 3. When x equals to 3, I get 3 times 3 minus 4 equals to 5a. That's 5 equals to 5a, so a equals to 1. When x equals to negative 2, that's negative 5b. So b equals to 2. So it's not too hard to do, right? It's not too hard to do. Let me just do it sideways. Therefore, going back to that integral, okay, this is 1/2 x squared plus x from 0 to 1 plus integral from 0 to 1 of 1 over x minus 3 plus 2 over x plus 2 dx. This is 1/2 plus 1 minus 0, right? And then the second part will be natural log of x minus 3 plus 2 times natural log of x plus 2 from 0 to 1. That's natural log of 2 plus 2 times natural log of 3 minus when x equals to 0, that's natural log of 3 plus 2 times natural log of 2. That's 3 over 2 plus natural log of 3 minus natural log of 2. Or 3/2 plus natural log of 3 over 2. But it's all computation. Once you are able to do partial fraction decomposition, then it's all computation. Okay. Now, I want to go back to this part here and show you another way to do it. Not necessarily a better way, but just an alternative way to look at that. Okay, just an alternative way to look at that. So let me scroll this down. Okay, that's integral of from 0 to 1. What's that? 3x minus 4. So 3x minus 4. And we have x squared minus x minus 6 at the bottom. Now, if the denominator is my u, if the denominator is my u, what is du? 2x minus 1 dx, right?
Yep.
Now, then I want to rewrite it this way. Okay, I still use in terms of x, okay? Still in terms of x. But I make it 3 over 2 times 2x minus 1. Okay, minus, now, so far 3/2 times -1 is -3/2. Plus what gives you -4? That's -5/2, right? So to compensate, to make up for that -4, I still need to subtract by 5/2 here. I know it's a bit tricky, okay, but my purpose is, take a look. This is the derivative of that, right? Okay, so then this becomes basically 3/2 integral of u prime over u du minus 5/2 integral from 0 to 1 of dx over x minus 3 x minus x plus 2. Okay, with some number here, right? Okay, now if I want to bring it back to x, if I want to bring that back in terms of x, this is 1, this is 0, this is 2x minus 1. But the way we massage that already makes sure that the derivative of the denominator is the coefficient on the numerator, such that this is basically 3/2 natural log of x squared minus x minus 6 from 0 to 1. And the one on the right-hand side, this is 5/2. Then you do that business. 3 minus -2 natural log of x minus 3 over x plus 2 from 0 to 1. Okay, so 3/2 when x equals to 1, that's natural log of 6 minus, oh yeah, minus natural log of 6 when x equals to 0, minus 1/2 natural log of 2/3 minus when x equals to 0 natural log of 3/2. This is equals to 0 minus 1/2 times parentheses natural log of 2/3 plus natural log of 2/3. That's 2 times of that, right? That's just for this part. That's just for this part, the yellow one. Sorry, I have negative here. Negative here. Okay, now you see that the one I did partial fraction decomposition, the one I did for this, give me natural log of 3/2. Thomas, it's different from what you get. Natural log of 3/2, is it different from negative natural log of 2/3? Can anybody tell me?
I remember you mentioned that they're identical because it's the reciprocal or the inverse?
Yeah, that's right. That's right. Yeah, because if you bring the exponent to the coefficient of that natural log to the exponent, that's just natural log of the reciprocal. Okay, so they are actually the same. That's, well, you know what? They may look different, but doesn't mean they are different. You know. Okay, you need to simplify them first. Okay. Yeah, what you see with Thomas at school is different from what you see Thomas at home. Okay, now that's a little skill that you may see here and there to help. Okay, now let's go back. We did number 19 earlier. What happened if, or do you want to do more? Is there anything more? Number 22, do you want to try? Let's try that, sure. Number 22. I wonder if I did number 22 in my lecture. I just don't want to do the same thing, though. Integral of ds over s squared times. I did? Okay, yeah, then find something else. Something more interesting.
I mean, they're all interesting.
Let's see then. You know what? Let me sneak peek into 7.5 because 7.5 is technique of integration. Mommy. Oh. Let's see. Okay, let me try number 6 from 7.5. Number 6 for 7.5 is integral from 0 to 1 of x over 2x plus 1 cube dx.
Can you do, after this one, can you do number 25 from 7.4?
Yeah, I can, but that's actually type number 3 already. That's not type 2. That's type 3 already. I will show you later on.
Okay.
Okay, I will show you later on. So partial fraction decomposition, that's x over 2x plus 1 cube. That's equals to something over 2x plus 1 plus something over 2x plus 1 squared plus something over 2x plus 1 cube. Okay, now then multiply by the LCD. Then on the left-hand side, we get only x. On the right-hand side, a times 2x plus 1 squared plus b times 2x plus 1 plus c. Is the audio cutting out for anybody else?
No.
Oh, you're okay? Let me address that later on. Okay, let me address that. Then let me use special value then when x equals to -1/2. So that's -1/2 equals to 0 plus 0 plus c. Oh, that's easy. 2 terms get killed right away. Get the c. Okay, then let's say when x equals to 0. When x equals to 0, I get 0 equals to a plus b plus c. Doesn't really help, huh? Yeah, doesn't really help. I know the c is -1/2, so 0 equals to a plus b minus 1/2, so a plus b equals to 1/2. Okay, let's see the grouping. You see that if you take a look on the x squared component, on the left-hand side, what is the coefficient of x squared? 0. Right? You see that? I mean, no x squared term on the left-hand side, just x term, no x squared. On the other hand, on the right-hand side, what is the coefficient for x squared? You get x squared only from here, right? That's 4ax squared. It's 0x equals to 4ax squared, right? So 4a equals to 0. Therefore, a equals to 0. Aha! So b equals to 1/2. I mean, it feels so good if you suddenly look at something as like, hey, you know what? If you look at it this way, I know the a is 0. Oh, if I look at this way, the c is negative 1/2. Then the b must be 1. Now, then looking back, that integral of x over 2x plus 1 cubed dx is equal to integral actually from 0 to 1, huh? 0 to 1. The a component is 0, but let me just write it down so that we are all happy. The b is 1/2. The c is negative 1/2. Okay, then when you integrate, you will get negative 1/4 times 2x plus 1. And then plus, I wonder what's that, plus 1/4 also. 2x plus 1 squared, but that's from 0 to 1. I think it's 1/8 instead, my bad. Not 1/4, it's 1/8. No, that's true. You know what, let me just do it right. I get frustrated. That's negative 1/2 integral from 0 to 1 of 2x plus 1 to the power of negative 3 dx. How do you integrate that? Negative 1/2 and then 1/2. Oh yeah, that's right, it becomes plus. Okay, and then 1 over 2x plus 1 to the power of negative 2 from 0 to 1. So yes, it is 1/8. So this is equal to.
Wait, where did you get the extra 1/2? Am I missing something?
This 1/2 here from here, this 1/2
Right.
here from here, and
Okay.
this 1/2 here from the chain rule. The coefficient
okay.
2. Yeah, the coefficient 2.
Okay. Oh, okay. Yeah, I should know better. Okay, thank you.
No, that's okay. Don't worry about it. Negative 8, so negative 1 over 9. Okay, 3, 1, 2 over 18. So that's 1 over 9. No, it won't be 1 over 9. Hold on. 3, 2, 1 over 18. It's just the algebra. I may make mistake there. Okay, I just want to do it fast, get over it fast. But you see, what happens if you have the power of 3? Then you need to start from the power of 1, the power of 2, the power of 3, like that. Okay, now how to find the coefficient ABC? That's quite challenging. Okay, now next, type 3. The QX, the denominator of that radicand contains irreducible quadratic. And it is without repetition. If it has irreducible quadratic without repetition. Let's say number 23. Did I do number 23 in my lecture video? I don't know, so I will just do it then. I don't remember. I just know that it's about 7.4 and 7.5. Okay, so I will do partial fraction decomposition. 10 over that factored guy is equals to something over x minus 1, right? Because it's x minus 1, then the numerator will be 1 degree less. Now, the thing is you have irreducible quadratic here, right? Then the numerator will be 1 degree less. But the denominator is degree 2, right? The numerator, therefore, must be degree 1. Okay, this is degree 2. Then this is degree of 1. Okay, just like this guy here, degree of 1, the top is degree of 0. Okay, that's how we break it up. Now then multiply by the LCD. The left-hand side becomes 10. The right-hand side is a times x squared plus 9 plus b times, I'm sorry, plus bx plus c times x minus 1. Can we choose the special value method, Thomas? Yes, but you have only one special value there, x equals to 1. So a equals to 1. But you have 3 variables. That's the thing. You have 3 variables. Okay, you have 3 variables. So how do we do that? And you can mix it together with, for example, a grouping method, or you choose other x. Let's say you can choose x equals to 0. When x equals to 0, left-hand side is still 10. The right-hand side is 9a minus c. Oh, this one is nice, right? When x equals to 0, it's only c here, it's negative 1 here.
Can't you just substitute the a for the 1?
After that. Yeah, after that.
Oh, okay.
Okay, so then together with a equals to 1, so 10 equals to 9 minus c. What will c be? 9 minus what give you 10?
1? I mean.
I knew it. I knew it.
Oh, I'm so sorry. I'm sorry.
That's okay. That's okay. Don't worry about it. Yeah.
Hey, I was close.
Hey, you are close, but you say I'm the one owing you instead of you owe me. Okay, when x equals to 2, yeah, we can do that. When x equals to 2, so 10 equals to 13a plus 2b plus c times 1, right? Okay, you know your a is 1. Your b is unknown. Your c is negative 1. So 2b is negative 2, b is negative 1. Okay, so now my integral of 10 over x minus 1 x squared plus 9 dx is equal to integral 1 over x minus 1 plus negative x minus 1 over x squared plus 9 dx. Okay, because my b is negative 1, my c is negative 1. Okay, then from here we integrate as usual. Okay, the first one is natural log of absolute x minus 1. Okay, this one here, let me break it up. This is integral minus integral x over x squared plus 9 dx minus integral 1 over x squared plus 9 dx. Can you tell what is the integral for the second term? Do this manipulation. 1/2 here, multiply the top by 2. Now notice that the top is the derivative of the bottom. So this is 1/2 natural log of x squared plus 9 minus, what is the integral of 1 over x squared plus a squared?
The tangent inverse of x over 3.
That's right. Okay, now let me show you another way to do this partial fraction decomposition. Again, the focus is actually on the partial fraction decomposition. To integrate that, I do expect you to know that already. Okay, now here you see the following. Yes, I will use x equals to 1 first, right? Because that really killed this term right away, right? Okay, but then I still need to find out what is the b, what's the c. Okay, and the method we used earlier, we chose other numbers. Okay, but beside that, we can also do the following trick. Okay, you can also do the following trick. Take a look on the x squared component. On the left-hand side, what is the coefficient of x squared? On the left-hand side, what is the coefficient of x squared? That's 0. On the right-hand side, what's the coefficient of x squared?
Isn't it just a?
A x squared, and then you have bx times x, right?
Oh, yeah.
Okay.
Okay.
So it will be a plus b, but you already know that a is 1, so b must be negative 1. Okay. On the other hand, if you look at the constant term, on the left-hand side, the constant is 10. On the right-hand side, the constant is 9a minus c. Yeah, if you look at the constant. The only way you get constant from the first term is a times 9. The only way you get a constant from the second term is c times negative 1. That's the only way. Now then, but we know a equals to 1. So c is negative 1. Okay, now the thing is, the method on the right-hand side, which we call grouping method, may not be a good method if you try to do everything, you work everything out without looking at which term will be special that give me the maximum benefit. Okay, notice that I don't play with the x terms, right? I only play with the x squared terms. The benefit of x squared terms is because x squared is not on the left-hand side. The x term, on the other hand, is a bit harder to compute on the right-hand side. At least when I look at that, it's like, nah, I don't want to deal with that. Okay, now, so in practice later on, when you work on this, try to experiment with different ways to work on that. Okay, if you try one way, it's kind of like harder to do, so try to look at another way. Okay, this is where it is quite beneficial if you do group study. So one person do this, another one person do another thing, and then you come back and compare. You know what? If in that situation I do this, it will be better. But in other situation I do that, it will be better. Okay. Now, Dorlins, earlier you asked me to go over one question. I forgot which one is that.
I think it was number 25.
Number 25. Oh yeah, that's right.
Yeah.
Number 25. So that's 4x over x cubed plus x squared plus x plus 1 dx. We need to factor the denominator first, right? So x cubed plus x squared plus x plus 1. Can you factor this? What method? You don't know this, drop the class. Go back to Algebra 1. Man, why don't you? It's 4 terms, so we know we use grouping, right? So the first 2 terms has common factor x squared. The last 2 terms, basically just x plus 1. So you have invisible 1 in front of that. Then I take x plus 1 out as the common factor. Inside I have x squared plus 1. Basically, this integral, the integrand becomes 4x over x plus 1, x squared plus 1 dx. You see? Now, let me ask you to do the partial fraction decomposition then. You do it. So 4x over x plus 1, x squared plus 1. What should I have on the right-hand side? What is the first denominator?
Isn't it a over x plus 1? And
Okay.
then the next one is plus bx plus c.
And then the denominator?
Oh, x squared plus 1.
Okay, please work it out. Yeah. It's actually, you are okay if you use ax plus b as long as the other constant you use c then. It's just a variable play chain, so don't worry about it. So yeah, so you can use c here and then this is ax plus b, that's also fine. Just don't use a here and then another a here and then another a here. You just love to get an a so much. No, you need to have some variation. One of my former student, the one that I told you that have an MD in New York, he took my calculus 3 and then transferred to UCLA, blah, 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 and going to New York for his MD. He's one person that I know contracted COVID, but don't show any symptoms. He's still very, very young. It's like 20 something, let's say 30 years old. But because he worked at New York hospitals, he contracted COVID without knowing it. Yeah, no symptoms. Well, anyway, at one time when he transferred to UCLA, he got a grade. One of his grade is not an A, so he got perfect 4.0 from West LA College, and then toward his graduation, one of his grade is B, and he gets so pissed off. I say that, no, if I were you, I will be happy that you don't want a grade that is all just constant A. You know, you should get some variation. And then one of his friend, also my calculus 3 student, also in medical school, say that, Thomas, I know one of your students actually have all C's. That's actually the best organic transcript. Do you know what she meant? That's the best organic transcript. At first I heard that, it's like, what do you mean by organic transcript? And then she say, you know chemistry, you know what I mean. So all the grades are C, 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 C. It's carbon chain.
I got a B in chemistry. I wouldn't know. I don't remember anything from chemistry.
Imagine the person who gets C's. Imagine if the person who gets C's. Actually, I like chemistry before. I like chemistry. For one strange reason, then I decide to do math, but I like chemistry before. Yeah, I can proudly tell you that when I graded from my high school, you know, I love math so much, right? When we did our high school in Indonesia, you need to take 7 courses. You need to take the exam for 7 courses, and that exam is the national exam on math. We call it MAFIA. MAFIA stands for math, physics. In Indonesia, physics is like this. This is Indonesian words, by the way.
You know, just reading it makes me think it's partly Spanish.
That's right. Yeah, we have the same root, and the way we read the alphabet also the same to Spanish. A, B, C, D, E, F, G.
Yeah, because my son's other grandmother, she speaks Tagalog. I swear, I heard her speaking to somebody in Tagalog, and I'm like, is she speaking Spanish? Like it really just tripped me out, and it's literally the same. Yeah.
Yeah, it's very similar. Yeah, because Philippines was actually colonized by Spain. As far as I know, there's now Indonesia was colonized by Netherlands. But the root words, the root language we have has very strong root in what is the word Melayu? Very strong in Spanish. Yeah. Now, anyway, Vietnam by France. Oh, Indonesia by Netherlands is actually worse. Yeah, though they say that if you are a colonialist, I'm not saying that colonialization is good, but if you need to be colonized, let it be colonized by England, by British. That's what people say. That's why people say. That's why Indonesia, even though it's a very big country, right? But our technology, our financial system, infrastructure, everything is worse than Malaysia and Singapore. You know, because England, when they colonialized you, I heard this, okay? Yeah, and I more or less agree with that, that they also try to build your country, while Netherlands, at that time, not now, of course, at that time, different mindset, right? They basically just try to suck out all the things you have in your country, you know. Yeah, it's really bad. It's really bad. Yeah. Let me show you this. Since this is story time, why not me showing you this? Indonesia has one place where we have so much gold in that area. Yes, it has so much gold. So much gold. Okay, now let me show you one place in Indonesia that American company Freeport-McMoRan took the gold so much out such that you just don't, I mean, when you talk about like they mess up the environment, this is how they mess up the environment. Let me show you which picture is that. Okay, take a look on this picture. Hey, I need the picture. Where's that? Where's that picture? Okay. Okay, you basically see this, right? You see, these are the mountain. These are the mountain. These are mountain here. Mountain. But you see this actually not a mountain. It was a mountain there. I'm not talking about hill. It's not a hill. It's a mountain. It's a mountain. They dig it so much such that that mountain not only disappear, it creates a deep valley in there. Now, it seems like it's small, right? Let's take a deeper look on that hole. That hole looks like this. Okay, so basically the truck go around, dig it all the way in. Okay, are you ready to see more? Yeah, it changed. It's so not okay. It's so not okay. It's just so effing bad. It's just so effing bad. Now, so this is pretty much a similar view. Not the same hole, by the way. There's a lot of mountain already disappear and becomes this valley, like really deep, really deep. Okay, now, so yes, they have trucks actually going around and drinking. What I want to show you next is how big is the truck. Do you see the truck? Do you see that truck? This truck is taller than my house.
That's taller than my house. Jeez.
You know, and if one of the tire actually fell off on you,
you die.
Actually worse than that.
Severely hurt.
If it falls on Thomas, you will get Thomas juice.
I don't know why that really made me laugh.
Okay, because this tire, the inside is not air. No, it's solid rubber.
Oh, no way. That's,
yeah, you see,
crazy.
it cannot be air. Why? Because you see, you are not moving just sands. Even if these are just sands, it's heavy enough. You're moving golds with much higher density than just sand, right? So no, it won't be air in there. You cannot fill it with nitrogen, you know, just so that it can move faster and lighter. Oh, no. Yeah, we are basically on break. Oh, am I recording this? No, we are not supposed to record this. Okay, let's continue recording. Then I multiply by the LCD. Now choose some nice number. X equals to -1. So I get -4 here. That's 2a here. That's 0. So a equals to -2. Okay, and then I still need B and C though. So how about x equals to 0? So 0 equals to A plus C. So 0 equals to -2 plus C, then C must be 2. Okay, and then the component of x squared component on the left-hand side, the component of x squared is 0x squared, the coefficient is 0. On the right-hand side, the coefficient of x squared is A plus B. So that's 0 equals to -2 plus B. Therefore, B is equals to 2. Now from there, then we have 4x over x plus 1 x squared plus 1 equals to -2 over x plus 1 plus, am I doing anything wrong?
No,
Oh,
I
no.
got the same thing.
Somebody took up my picture or what? Took the picture that I talk about those. Okay, B is 2 and C is 2 over x squared plus 1. Oh, he took a picture of his answer. Okay, good. Then how about the integral for this then? The integral of 4x over x plus 1 x squared plus 1 dx is equal to integral of -2 over x plus 1 plus 2x plus 2 over x squared plus 1 dx.
I have a quick question, Thomas.
Okay, go ahead.
I usually go straight into the integral instead of writing it twice.
You can. It's okay. Don't worry about it.
Okay. I was wondering if I could skip that step.
Yes, you can. You can.
Thank you.
Yeah. And then the first term, the first integral becomes -2 natural log of x plus 1. Now, the thing is, the second term here, I rather just split it. Now, it does take some practice and wisdom to know what to do at what time. Okay, the first term is easy. You can see that right away. That's a natural log, right? Now, how about the second term?
Second term is tangent inverse of x plus 2.
That's that one.
Yes,
Yeah.
that one.
That will be 2 tangent inverse of x, of course, plus constant. How about the middle term?
Isn't it 1/2 the natural of x squared plus 1? Wait.
You don't need
Yeah,
1/2
yeah.
anymore. You don't need 1/2 anymore. But you are there.
Okay.
Yeah, you are there. Well, because the derivative of this is that.
Yeah, because I took
Right?
it out. I did it the long way.
You just like it long.
I do.
Okay, let's continue. Any other question?
You mean questions from the book?
Yes, but before we go on, let's see number 36. This one is effing fun. And let me tell you why it's so fun.
Oh, you did this in the lecture, I think.
Oh, yeah. Okay. So sometimes we focus on, we focus so much on the partial fraction decomposition that we don't realize, hey, you know what? If I do my U substitution, if I do my U substitution, then du equals to 5x to the 4th plus 15x squared plus 5 dx, which I can factor the 5. So this is now equals to du over 5 over u. That's 1/5 natural log of u. End of story.
So when you said this one was hard, do you mean like when you look at it and you think of how to approach it, you would expect us to?
It's more about tricky. This one is a curveball. Because we were talking about, we were dealing with partial fraction decomposition, right? So when you see this question, what do you have in mind first? You want to factor this.
True.
Right? That's what, and then you will get like, oh, how do we factor this? Suddenly I don't know how to factor, blah, 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 blah. And then when you look at that further, hey, you know what? I already have what I need. On the top here is a factor of the derivative of that blue one. You know, okay. But for you to be able to see that, you need to have some, I should say some maturity level. Like, I mean, let's put it this way. It's like suddenly off topic, right? This number 36 suddenly off topic question. Yeah, the technique you use has nothing to do with partial fraction decomposition. No, not at all. You know. Okay. Well, anyway, choose more questions, especially number 39 to number 51.
I was going to ask you to do number 35.
Number 35, okay. That's integral dx over x times x squared plus 4 squared. We have a test next week. Yes, next Wednesday is your test. Next Wednesday is your test.
What are the sections that are going to be on the test?
Up to 7.3.
Oh, okay.
Does that include 7.3 or up into that one?
Including 7.3.
Okay.
Partial fraction decomposition 1 over x squared plus 4 squared. This is equals to a over x plus bx plus c over x squared plus 4 plus dx plus e over x squared plus 4 squared. Wow.
Could you explain the a over b?
No, I cannot explain that over a over b because it should not be b.
Okay.
Okay, so now I multiply by the LCD, but you know this will be quite painful. So this is 1 equals to a times x squared plus 4 squared plus bx plus c times x squared plus 4 plus dx plus e times x. I only have one special number though, when x equals to 0. When x equals to 0, I get 16a plus 0 plus 0. So a equals to 1 over 16.
Did you do the x squared term?
X squared term, what do you mean?
Like the grouping?
Yeah, okay, let's take a look on that. What is the degree though? The degree, the highest degree is x to the 4th, right? So x to the 4th component on the left-hand side, the coefficient is 0. We have 0x to the 4th. On the right-hand side, we have ax to the 4th plus bx to the 4th. And those are the only x to the 4th we have. on the right-hand side. But we know A already, so the B comes naturally. Okay. What else? Seems like I have no other way, huh? I mean, you can just continue, like, let's say x equals to 1, then what happened? And x equals to -1, what happened? You know what? Let's do that. What happened when x equals to 1? Then on the left-hand side, I have 25. On the left-hand side, I have 1. On the right-hand side, I have 25a plus 5 times b plus c plus, when x equals to 1, that's d plus e. Too many variables. When x equals to -1, what happened? 1 equals to 25a plus.
I also have a quick question, Thomas.
Okay.
When x is equal to 0, isn't that 0 on the left side? Not 1?
No, the left-hand side is constant 1.
Oh,
right? The left-hand side is constant 1. So
I thought you changed that by plugging in the 0 to the left-hand side. No?
Yeah, if you plug in 0 to left-hand side, you don't have x there.
Oh, okay.
Right? If that were x or x squared or x cubed, yes, it becomes 0. But no, it's already 1 as a constant.
Got you. Sorry, thank you.
Okay. And then let me see here. When I plug in x equals to -1, so this is 5 times -1, that's -5. But this is -b plus c, right? And then the last term, when x is -1, there will be d minus e. Oh, okay. So it seems like we can do something here. 1 equals to 25a plus 5b plus 5c plus d plus e. 1 equals to 25a plus 5b minus 5c plus d minus e, such that when I subtract, I get 0 equals to 10c plus 2e. I wonder if it helps. So 5c equals to -e. Not that much help. Let's see further. How about the x cubed term? The component for x cubed. So, like I use special value method and I mix it with grouping method. The x cubed component on the left-hand side has coefficient 0. On the right-hand side, do you have x cubed from this term? Do you have x cubed from this term?
I would think yes.
Are you sure?
No.
Let's foil that. I mean, we can foil them first and then see better. Let's do it. Oops.
Would it be the middle term, the c?
That's what I have in mind.
Okay.
But let's foil that first. So 1 equals to a times x to the 4th plus 8x squared plus 16 plus, okay, that will be bx squared plus cx times x squared plus 4 plus dx squared plus ex. Okay, let me just leave it like this here.
So it's only c.
Is it right? Yeah, so that's bx to the 4th and then 4bx squared plus cx cubed. Oh yeah, you're right. Plus 4cx plus dx squared plus ex. Okay, so yes, we already get the x to the fourth component. How about x cubed? I mean, x cubed component. On the left-hand side, it's 0. On the right-hand side is only c, huh? Okay, so c equals to 0. We already get a, we already get b, we already get c. Oh, but we also have here, so e must be 0. Right? E must be 0. And just plug in all the numbers in there then. So 1 equals to 25 over 16. The a is 1 over 16, right? And then plus actually becomes minus 5 over 16 plus c equals to 0 plus d plus e equals to 0. So 16 over 16 equals to 20 over 16 plus d. So d must be negative 4 over 16 or simply 1/4, negative 1/4. Oh, I don't like that. Okay, let's put everything together. Do you remember the question? So integral of dx over x times x squared plus 4 squared, that's equals to integral. Okay, 1 over 16 over x plus, what is my b? Negative 16. And c is 0, right? Yeah, b is negative 16. So this is negative 1 over 16 x squared plus 4. Okay, plus my e also 0. What's my d? My d is negative 1/4. So negative 1/4. Hold on, I have an x here. And this is also an x here. X squared plus 4 squared dx. I hope I don't write anything wrong. C and E. I really hope I don't do anything wrong, seriously. So this will then be 1 over 16 natural log of absolute of x minus 1 over 16 or 1 over 32. Yeah, 1 over 32 natural log of x squared plus 4. Okay. Okay, what yo, Anthony? Am I okay? Which part is terrifying? You can just slow down a little bit and then do the substitution. Oh, thunder. Oh, okay. So this is minus 1/4 integral x over x squared plus 4 squared. Let me just use substitution here explicitly. So u equals to x squared plus 4. So du equals to 2x dx. And that's another 1/2. So du over u squared. So that will be 1 over 16 natural log of absolute of x minus 1 over 32 x squared plus 4, and then plus 1 over 8 over u, but my u is x squared plus 4, plus constant. I'm missing something here. I'm missing natural log. Okay. If I make mistake, it must be some computational mistake. Oh, where are you now, Shane? You said that you're not in North California right now? Humboldt. Oh, okay. That's for number 35. So yes, it's kind of painful with the coefficients, but you just need to really work it out though. Okay. Yeah, you just really need to work it out. The 14, the 4 in that number 35 really messed up. If that were 1, it would be a lot nicer number. Okay, let's randomly pick some questions between number 39 to number 51. Pick 2 questions maybe from those. Number 41. So it involves some substitution. So this is dx over x squared plus square root of x. I will substitute my u equals to square root of x. Okay, and you can do it this way actually. You don't need to do the derivative directly from there. You can write it u squared equals to x and then do the derivative. Do you think that's better? Right, then you differentiate that. Instead of you do the derivative du equals to 1 over 2 square root of x dx, and you try to solve for dx, and you need to change that square root of x in terms of u again, you know, boring. Okay, so now my integral becomes 2u du on the top, that's for the dx. Okay, x squared becomes u to the 4th. Square root of x is now u. Oh, we can cancel one of the u. So 2 du over u cubed plus 1. Okay. The thing is, what is u cubed plus 1 when you factor it? That's sum of cubes, right? Now let's do the partial fraction decomposition here. 2 over u plus 1 times u squared plus u plus 1 equals to a over u plus 1 plus bu plus c over u squared plus u plus 1. It's irreducible. U squared plus u plus 1 is irreducible. So multiply by the LCD, you get 2 equals to a times u squared plus u plus 1 plus bu plus c times u plus 1. When u equals to -1, I get 1 and 0. Oh, yeah, because -1, this is 1, this is -1, and I still have 1, right? While the second term, when u equals to -1, it turns out to be 0. Okay, so a equals to 2. Now, how about the rest? Let's choose u equals to 0. Hopefully that helps. So when u equals to 0, I get a plus c. Okay, then c equals to 0. Am I okay? Let's do one more. How about when u equals to 1? The a is 2, the c is 0. So b is -2. So now this integral becomes integral of 2 over u plus 1 plus -2x, I'm sorry, -2u over u squared plus u plus 1 du. Let me move the negative here. So far, am I okay? So I get my A, that's 2, my B is -2, my C is 0, so that's what it looks like. Okay, so the one here, that's 2 natural log of u plus 1 minus. Then you try to integrate this, right? Integral of 2u over u squared plus u plus 1 du. But let me teach you something first. Suppose I do another substitution. Okay, let's say my w equals to u squared plus u plus 1. What is my dw? It's that one, right? So this is what I will do. I will do this manipulation. Take a look. I will do this manipulation. I will plus 1 here and then minus 1. It's basically adding 0, right? But my plan is this is the derivative of the denominator, right? You see it here. Okay. So I can rewrite that as 2 natural log of u plus 1 minus integral of 2u plus 1 over u squared plus u plus 1 du plus integral of 1 du over u squared plus u plus 1. Yeah, I massage it to be like that. I massage that to be like that. So here we have 2 natural log of square root of x plus 1 minus natural log of u squared plus u plus 1 plus, now the last term here, I need to massage even further. This is du over u plus 1/2 squared plus 3/4. Is it right? So this is 2 natural log of square root of x plus 1 minus natural log of x plus square root of x plus 1 plus, this one is nasty. If this is my a squared, then my a will be square root of 3 over 2. I will do the reciprocal. That's 2 over square root of 3. Tangent inverse u plus 1/2 over radical 3 over 2 plus constant. Tangent inverse, multiply the top and the bottom by 2. 2 square root of x plus 1 over radical 3 plus constant. Dang. What number is that again?
41, I think.
But why
Yeah, it's 41.
I think I write something wrong. I have a typo and I didn't realize that until I look at that question again. Can you see my mistake? Fudge. Man, I work so hard. I work so effing hard. I don't think I did anything wrong except I copied the question wrong. I'm missing an X here. I'm missing an X here. It's just messed up all the way. Man. That hurts. That hurts. That hurts. Yeah, we made a new question. Okay, so I'll call this 41 star. Okay, let's do the real 41. Write the question properly, Thomas. Dx over x squared plus x square root of x. With that substitution we made, u equals to square root of x, u squared equals to x. 2u du is dx. So now this becomes integral 2u du on the top. Here we get u to the fourth. Here we get u cubed. Cancel one of the u. Okay, we then factor u squared. Oh, much better, man. Much better, man. So 2 over u squared times u plus 1 equals to a over u plus b over u squared plus c over u plus 1. Because you have u squared, so you have to do it u and then u squared, right? And then multiply by the LCD, 2 equals to a u times u plus 1 plus b times u plus 1 plus c u squared.
It'll be AU squared, right?
AU.
Oh, no, never mind.
Yeah, we cancel one of the u. Okay, so when when u equals to 0, I get b. Oh, that's nice. When u equals to -1, I got c. Oh, I hope it's just like that all the time. Then what other number I should try? Let me try -1 and u equals, no, I try -1. U equals to 1. When u equals to 1, I have 2 equals to 2a plus 2b plus c. So that's 2 equals to 2a plus 4 plus 2. So a is -2. That's way too nice though. All of them even number? Not really common.
Maybe it was because you messed up on the other one. So the universe is trying to be nice.
Okay. I wish the universe is that considerate. So this is the u equals to integral, yeah, -2 over u plus 2 over u squared plus 2 over u plus 1 du. So So this is -2 natural log of absolute of u minus 2 over u plus 2 natural log of absolute of u plus 1 plus constant. I really want to put all the natural log together. So, well, natural log 2 natural log of u plus 1 over u minus 2 over u plus constant. Now replace those u's back. 2 natural log of u square root of x plus 1 over, actually I don't need to, huh? No. I have that square. Don't put them together. So this is -2 natural log of square root of x minus 2 over square root of x plus 2 natural log of absolute square root of x plus 1 plus constant. But this one here, I can bring the -2 to the 2 to the exponent. So this is natural log of absolute of x. Okay, I better get it right. I want to check my answer. I work hard for this. Maybe I'm sleepy too.
Wait, sorry, Thomas, could you explain what you did? Did you get rid of the 2 by making a new constant? Or
well, because because this, I bring this exponent to this becomes the exponent.
oh, okay.
Right?
So you just manipulated it to get rid of the
Yeah, to get rid of the square root.
oh, okay, I see.
So this
Can I ask why is that? Do we need to do that, or because we do have a
you don't have to. I just think like our textbook may want us to do that.
Okay, I got you.
This is number 41. Oh, actually our textbook doesn't do that. Our textbook just leave it like that. Our textbook just leave it like that. Yeah, our textbook just leave it. But you can, if you want to do it this way, that's you can. Our textbook leave the answer here, and they don't even use absolute sign.
Now, could we still do the 2 natural log of x plus 1 over radical x plus 1 over radical x? Would that still be right too?
Yeah, I will take it. It's just a simplifying thingy.
Right. I figured that's what we would normally do.
Yeah.
Perfect.
Okay. Now that's for this question. I hope that's the last question. Oh, okay. Now, the reason I don't really spend time with 7.5, and I would just ask you to start working on that on your own, is because that 7.5 is just one sentence. Oh. 7.5 is a strategy for integration. Basically, everything put together. Okay, so I would like you to work together. Yeah, that's one sentence. Everything put together. I would like you to work on those questions. Maybe you do odd numbers, okay? And then on Monday next week, then you ask me questions from there. Okay? And I would like you to do it like what Dorleans did. If we get good at 7.5, we are probably set for the test. Very likely, yes. Even though 7.5 is more into integration, while in chapter 6, we still have derivative. But I also think that way. Okay. Now, don't forget that on Saturday, 8 o'clock, I will have my office hour. Okay. But I will not go online until somebody say, Thomas, can you go on? But I prefer what Dorleen's did. This is what Dorleen did yesterday. Okay. She took the pictures of her work. Okay. So she already did some, right? And then she said, Thomas, I get stuck here. Then I basically screenshot what she gave me, screenshot of her screenshot, and then I put it on my notes, and then I continue working from there. You see?
That was really helpful because he wrote basically on my problem and like circled where I went wrong.
Yeah, and most of when I saw your work, Dorleen's, most of them actually okay. You just get stuck, okay, but you didn't do mistake. Like you went on correctly, but you just don't know how to go on. Instead of like you didn't do it right since the beginning, for example, right? Okay, yeah. So yes, on Saturday, 8 o'clock in the morning, I will be available, but I need somebody to remind me, Thomas, can we meet on Saturday? And if you take a look on our what's that, Zoom. If you take a look on our Zoom, you see that on Saturday now I have 8 o'clock Saturday office hour. Okay, start from 8. You see what I mean? Okay, I will not go there until you tell me to go there though. Okay, it's my Saturday too. Okay. Yeah, that's my problem with Calc 2 is figuring out how to approach it. You really hit it right. Most of the time, those students who really want to learn, your issue will be, Thomas, I look at that question, I don't know how to attack that. And the reason they put that this section 7.5 is because that's what you need to practice on. Okay, there's no single silver bullet that when you see this, do this, when you see that, do that. Especially, I have shown you before, some problems can be done with 2 different ways. In fact, I have seen one problem can be done in 3 significantly different ways. Okay, no single way. Okay, so by practice. Okay, that's the only way you can really get it. That's how I get it before. That's how you will get it too. Okay. But don't get discouraged though. It's the part of the practice. That's part of the learning process. Okay, see you then on